Hello again, guys. Back at it for another week of pre-calculus. Today is the big lesson I told you about. So we're going to do 1-3, 1-4, and 1-5 all today. I just titled it All Things Equations because the three titles were way too long to fit on this page. Let me get my stuff organized. I actually was on top of it and have stuff today, so that's good. I can actually, use a real calculator to do calculations. Okay. So equations. Remind you, x-intercept is where x equals 0 and the line crosses the x-axis. Y-intercept is where y equals 0 and the line crosses the y-axis. Slope, also notated as m. Usually how we find slope is we do y2 minus y1, x2 minus x1, if we have points x1, y1, and x2, y2. All right, we have 4 types of slopes here. The first type is a positive. So it's heading either towards the positives or the negative, which would be the same as a positive. A negative slope, which is this direction. A 0 slope, which is here, so we have 0 up or down. And undefined slope, if you think about walking, okay, it would be impossible to walk up this, undefined. Here are some equation forms for you. The first one is standard form. And that is ax plus by equals c. A is going to be a positive number. All right. You'll see equations in this form, but usually in order to graph or use our equations, we aren't going to want them in this form. The next one is slope-intercept. So our y equals mx plus b form. Remember that m is slope, which we could find using this information up here. And b is our y-intercept. And another form of equations that we're going to talk about is point slope. Okay, so that's going to be y equals m times x minus x1 plus y1. M is your slope, x1, y1 is a point. Okay. We'll talk about point slope and slope-intercept and how they relate to each other. The nice thing about point slope, it tells you a point to start at, and it tells you the slope of that line from that point. I would say that typically slope-intercept is the one that we use the most. All right. Zeros of the function f. So the values of x where f of x equals 0, or also the x-intercept. So if you see where it says zeros of a function, we're just talking about the x-intercepts or where our function equals 0. All right, so lots of problems. So we're just gonna go through these. This is a part where in class, I would say pull out a whiteboard and let's work on these together. Okay, but since you don't have a whiteboard right now, I am just going to, since we're not together, that's the bigger deal, I'm just going to go through and show you how I would do them. I'll use these colors to match what I'm doing, okay? So, first one right here, 3x minus y minus 2 equals 0 using x and y intercepts, okay? So what we're going to do is we're going to plug in 0 for x, solve, and then 0 for y, solve, and then we'll have intercepts to graph. Okay, we'll see how I do this because I didn't leave myself much space to work. See what magic I can pull here. All right, so I'm going to plug in 0 for x. Okay, I want to solve. This is going to go away. I'll move my y over here, so I'll have y equals -2 if I add it to both sides. Okay, so my point would be 0, -2. That'd be 1 point, or 1 intercept. So now let's plug in a 0 for y. So I'll do 3x minus 0 minus 2 equals 0. Whoops. So I'm going to put a 0 in here. So that's going to go away. We got a minus 2. Let's add it to both sides. 3x equals 2. Divide by 3. X equals 2/3. So we're going to have 2/3, comma 0 as our other point. Okay, that's not a great point, but we'll go with it. So this one's going to be our blue line. So I'm going to go 0, -2, and 2/3 0. And my line is going to look something like that. Seeing if I can find a quick straight edge I could use. Oh, here we go. Perfect. We'll use a page from the book Shapes that is just sitting here. You know, the straight edges you find. There's my line. It's really poorly through my points. Okay. You can probably do better. The heart page did not serve me well. All right, next one. I'm going to use my colored pencils to match. So using slope and y-intercept. So on here, we're going to check, is this in slope-intercept form? Y equals mx plus b. Yes, it is. So my slope is the m. M is going to be next to the x, so that's 3/4. My b is going to be this unit, -2. Remember, b is the y-intercept. All right, so we're going to plug that on my graph. So I'm going to plug my y-intercept of 2. Funny, it's the same point. And I'm going to go 3/4. So I'm going to go up 3. 1, 2, 3 over 4. 1, 2, 3, 4. Okay. I could keep going. 1, 2, 3. 1, 2, 3, 4. If I want to make a better line, we'll see if the heart book serves us better this time. I learned I have to give myself some space. Okay. Whoop, almost. Okay, so that's number 2. Remember, I'm color coordinating them so we'll know. Okay, here's my next equation. If I got something like this, I'd probably turn it into y equals mx plus b. So I'm gonna, let's see, 2x plus y equals 5. I'm gonna minus 2x from both sides. So I'll have y equals -2x plus 5. Why did I write it in that order? Because y equals mx plus b, our x comes first. So my slope is -2. My b, or my y-intercept, is 5. We are just hanging out. We like these -2s. Okay, so our b is 5. So 1, 2, 3, 4, 5. That's my starting point. Okay, my slope is -2, or -2 over 1. So I'm going to go down 2 over 1. So I make sure it's in the negative direction. Down 2 over 1. If you have a real ruler, whoop, we're going to go with it. That was not grand at all. That was terrible. Heart book, you're hurting us. Okay. All right. X equals -2. So every single place that x equals -2. All right. So we're going to go, let's think about it. If we go down here, is this x's or -2? No, that's x's are lots of numbers. So over here, if we draw a line here, x is -2 no matter what. So this right here, free-handedness one, x is -2. All right, next line, y equals 4. So if these are the x's, horizontal must be y's. So we go up to 4, 1, 2, 3, 4. Y is always 4 right here. Those look the same. I'm going to label them. Y equals 4. If you could actually see these, you would tell that they're beautifully different. Okay. 6. Write an equation in slope-intercept form, then graph it. The slope is -3/4. Y-intercept is 3. So we're going to say our slope, M, whoop, that's the wrong color, is -3/4. It's okay, you can laugh at me. My slope-intercept is 3. My husband sits and listens to me record these and just laughs the whole time. So, all right, so Y equals MX plus B. Done. We wrote our equation, now graph it. So we're going to use our B of 3, 1, 2, 3. And my slope is 3/4. So I'm going to go down again. 1, 2, 3 over 4. 1, 2, 3, 4. Okay. The biggest thing is you can take a peek back at your notes if you're not sure which way to go with your slope. This is negative. This is positive. Okay. All right. Okay. Gotta pull out the heart book again. See if she serves me better this time. You know, it'd probably be helpful if I just brought a ruler. There you go. Not bad. Okay. Last one. Write an equation, then graph. So slope is -6 through this point. So I know my slope is -6. And I know I have the point 1, -3. Okay. I don't have a B. So what I'm going to do is write out what I know. I know that I have Y equals -6x plus B. So what I'm going to do is I'm going to plug this in for X and Y over here. So I'm going to have -3 is 1 plus B. Now I can solve -6 times 1, so we're going to add 6 to both sides. And B is going to equal 3. So I can write it into my equation. Y equals -6x plus 3. Okay, so that answers that question. Now let's graph it. My B was 3, 1, 2, 3. And my slope was 6, 1, 2, 3, 4, 5, 6 over 1. Remember this is the same as 6 over 1. Okay. Last time book. And oh goodness, that one was going to be real bad. We're going to try it again. Oh, last one was rough. Okay, you guys get it though. Okay, so there you go. There's all different kinds of questions you're going to see. All right, let's go on to the next page. So I think that was 2 lessons right there. Bam, done. Okay. Parallel lines. Important thing about parallel lines to remember is that parallel lines have the same slope and they have no points in common. Okay. All right. Perpendicular lines. Perpendicular lines are opposite reciprocals. Their slopes are. So what does that mean? So they're M. If it's the opposite, we're going to use a negative sign. And if it's a reciprocal, we are going to flip it. So we're going to have 1 over M. I'll show you some problems and you'll see the opposite reciprocal. So if you had a fraction, you would flip it to become, you would flip it the other direction. Okay, and then you change the sign. So opposite here, I could say maybe sign change. All right, and then we would say that things are coinciding if they are the exact same line. So is the graph parallel, perpendicular, coinciding, or none? So we got 3 sets of lines. I'm going to work through how I would figure these out. All right. So on my first one, what we could do is we could match up our slopes. All right. So what do we know about our slopes? Well, are they the same slope? No. Are they opposite reciprocals of each other? No. So, are they going to be the same line? No. So this is none. Okay. They don't have anything possibly in common. All right, let's just look at this one. Let's look at our slopes, because that's the big giveaway to begin with. So -6 and 1/6. Are those the same slope? Nope, they're not the same. Are they opposite reciprocals? So sign change. Yes, our sign changed. And then does it become 1/? Yes, it does. Awesome. They must be perpendicular. Okay. We don't care about where their y-intercepts are because they're going to be perpendicular no matter what if our slopes satisfy these slope things above. Okay. All right. Let's move this bottom one into y equals form so we can see what's going on there. All right, so we're going to move our x, and we'll have -y equals -x minus 8. Let's multiply it all by -1, so that we'll have x plus 8. So we'll have y equals x plus 8. Okay. All right, so this one and this one, I'll cover it up for now. Those two lines, do they have the same slope? Yes, they do. Do they have the same y-intercept? Nope. So that means that they're going to be parallel. We need to check the y-intercept because if they were the exact same, then they would be coinciding lines. But because they are different but the same slopes, we know they're parallel to each other. All right, last one. Okay, same thing. Let's move everything into slope-intercept form. So we're going to get the y by itself. And we're going to divide by 2, -2. And put that m first. So -4 divided by -2 would be 2x. 16 divided by 2, -8. So we have y equals 2x minus 8. Let's look at our two lines. Same slope? Yep. Same thing? Yep. So that means that they are coinciding. Okay, so this is how you would check for parallel, perpendicular, or coinciding. All right, so the next thing it's going to ask us to do is to write the equation of the line parallel and perpendicular to this line. So what we're going to do, oh, and we have this point over here. So what we're going to do is we're going to start with parallel. All right, let's put this in the slope-intercept form to figure out what this line is. Okay. Okay, so I got -y equals -5x plus 16. Multiply it all by -1. Okay, that's just to get rid of this negative, right? Okay, so this is my equation of my line. So we want a line parallel that goes through this point. So what we're going to do is we know that we need parallel lines have the same slope. So we know that we're going to have a slope of 5, and we know we're going to use this point. So just on the last page, we're going to do the exact same thing to create an equation. So I'll do y equals 5x plus b. Then I'm going to plug this in, my x and my y. So 9. So I have 50 plus b. B equals 41. So I'll have y equals 5x plus 41. So this is the equation of the line. Whoop, did I do something wrong? Oh, yeah. You guys would have got me. Okay, 50 minus would be a -41. So I'm going to rewrite this. So y equals 5x minus 41. Okay. Get rid of my book. My ruler. Okay, so there we go. That's a parallel, that is the parallel line, same slope, that goes through this point. Okay. Perpendicular. Okay. We can use the same line, y equals 5x minus 16, and it tells us perpendicular. So what does a perpendicular slope have? Okay, it's the opposite, so the opposite of 5 is negative, and we would do 1 over 5, so that would be our slope. And we know it needs to go through this point. So we're going to do the exact same thing as over here, but we're going to use negative 1/5 as our slope this time, and plug these in. So we'll have 9, negative 1/5, 10. So now we're going to solve this. So we'll have negative 2, so 10 divided by 5, 2, plus b, plus 2, plus 2, b equals 11. So we'll have, and then we need to put this b back into this equation right here. Negative 1/5 x plus 11. Okay. And that is going to be my perpendicular line. All right. That is all. 3 lessons, 21 minutes, not bad. Here's your homework. It's also posted on Classroom. These two in the book, it asks you to put it in standard form. I'm totally fine with slope-intercept form, and I put the answers for the slope-intercept version of those in Classroom as well. So take a peek for those. But if you have any questions, let me know. Have a wonderful day.